Hey, this is the rapid review video for using area models to multiply decimals when you have a decimal times a decimal and no whole numbers. So let's take a look at the model you see on the screen. This is an example of an area model for a decimal times a decimal. But how do we read it? Again, we have to go back to what we talked about in the last video. Area equals length times width. In this case, our lengths and widths look a little bit different. But still, we know that lengths are going to go across and widths are going to go up and down. So when I look at this model and I go across, I see that the red is going across. The red goes across in 1 line, 2 lines, 3 lines, 4 lines. But we don't call those lines, right? We call them rods. And we know that each rod represents 1/10. So in this case, our length is going to equal 1/10, 2/10, 3/10, 4/10. Our length is going to equal 4/10. Well, what about our width? Let's look at our width. Our width's going up and down. We can see that the blue is going up and down. Again, these are rods. They're just going in the different direction. So we can count it as 1/10, 2/10, 3/10. So we can see that our width equals 3/10. Again, we have to know what problem it is this model is solving. So we go back over here to area equals length times width. And we see that the problem that we're solving is 4/10 times 3/10. Well, how do we read the model? In this case, we're again looking for what takes up the area. But it's not the area of the entire hundreds grid. Instead, it's the area that was covered in both red and blue within our 2 decimals. And we can see here that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 cubes that were covered by both the blue and the red. Well, what does a cube represent? It represents 1/100th of a whole. So if we have 12 cubes, then that means that we have 12 hundredths. So 4/10 times 3/10 equals 12 hundredths. Pretty cool how the answer is right there in our model, isn't it? Let's look at another one to make sure you really got it. Look at this model. Another model that's showing us a decimal times a decimal. Remember, area equals length times width. Since these are area models, that formula is going to help us out. Length goes across, width is going to go up and down. So what's going across? In this case, we see that the pink is going across, but there's not a lot of it, right? There's only 2 rods colored in. 2 rods represents 2/10, so we know that our length equals 2/10. What about our width? Our width goes up and down. We can see that this purplish blue is going up and down. And so we can see there's 1, 2, 3, 4, 5, 6. There's 6 rods going up and down. So our width is 6/10. The first thing we need to do is figure out what problem we're solving. If area equals length times width, then that means that the problem we're solving is 2/10 times 6/10. Now that we know the problem, we can find the solution. Remember, area is the space within. So we're looking for the space that was taken up by both decimals, the pink and the blue. And it's in this nice, pretty fuchsia color right here. So let's count and see how many cubes were taken up by both colors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look at that. It's 12 cubes as well. If we remember from what we just said, each cube represents 1/100th. So 12 cubes would represent 12 hundredths. So 2/10 times 6/10 equals 12 hundredths. So that's how you read area models when we're looking at a decimal times a decimal. Not too bad, right?